When you're programming, integers behave differently than they do in math class, and these subtle differences can make your programs not work the way you expect. The differences come from the fact that in a computer, integers have a fixed length, meaning the machine has a fixed number of bits for each integer. For a more detailed video on how integers are really stored, check out the video at the top of the screen. For this discussion, the fact that they are of fixed length means that there is a finite range of values they can take on. When we try to go beyond that range, the wheels fall off. For a minute, think about the addition you learned in math class. When you add two numbers with 4 digits, there is some chance that you will carry out of the 4th digit and require a 5th digit to hold that carry. The same thing happens in the machine. However, if an integer in the machine is given 8 bits as its fixed length, the number has to fit in the lower 7 bits, and the uppermost bit is saved for holding the sign. If you add two numbers and they carry into that bit, many languages will just let that carry right into the sign bit without telling you that anything has gone wrong. The effect is that when you add two positive numbers, and the result is negative. For example, look at this code. Math.pal 231 is 2 to the 31st. That's the biggest number a Java int can hold. If we add 1 to it, the result is negative. No warning, no exceptions thrown. The machine is perfectly content with that result. The same thing can happen at the other end of the number line. If subtraction would take you below the most negative number you can store, the result will suddenly be positive. This code outputs a positive number. Again, the computer doesn't tell us that anything went wrong. You have to worry about this kind of error in intermediate results too. Look at this code. You think it could ever output no? It looks like that multiply by 100, then divide by 100 should undo each other and leave us back at x. If I give it a 5, there's no output. That's what we would expect to happen. However, if I give it 300 million, it outputs no. What happened? Well, when it multiplies 300 million by 100, the result is bigger than an int can hold, and the multiplication overflows into the carry bit. The result of that multiplication is a really negative number. Divide that by 100 and we certainly don't get back to the number we started with. So, because they have fixed width when we store them, the first thing we have to worry about with integers is what happens when our calculations result in something bigger than the fixed width can store, and the problem could be with an intermediate result, not just with the final result. The other thing we have to worry about with integers is how the machine divides them. In many languages, there are two kinds of division: real division, which is the division you and I know and love, and integer division, that just quits at the decimal point. Some languages make the choice of integer versus real division explicit. However, in many languages, the choice between integer division and real division just depends on the types of the operands of the slash operator. That can make the math confusing. For example, look at this comparison. In math class, those would be equal because multiplication and division are commutative. However, in these languages, both of the slashes would be interpreted as integer division. So 33/10 is 3. 3 times 4 is 12. On the other side, 33 times 4 is 132. 132/10 is 13. There is one other way that division can be interpreted: floor division. The floor of x is the greatest number less than or equal to x. Floor division is like integer division in that it'll give you an integer, but instead of just quitting at the decimal point, it gives the floor of the real result. For positive numbers, floor division and integer division give the same values, but for division that results in a negative number, the results are different. So, you need to pay attention to how your language interprets the slash operator and whether it gives you an explicit way to code integer or floor division. Those are the differences for integers. Check out the next video to see how real numbers are different on a computer than in math class.